Okay, so yeah, let me just start by reading through this question. So the problem says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Okay. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number itself. Okay, so we have 2, 4, 3, 5, 6, 4. 2 plus 5 is 7. 4 minus 6, or 4 plus 6 is 10, and that carries over. So it's 4 plus 4, 8. Okay, so I want to ask some, okay, interesting. Let me think real quick. Okay, what if one of the linked lists' length is longer than the other linked list? What should we do at this step? Should I? Okay, so they should all have the same length. Should I assume the inputs are always non-negative? Okay. And should I return the result as a newly created linked list? Or can I just modify the current input? Or it doesn't matter. Okay. And then I see that we're carrying over digits. So I gotta think about how I can implement this. And are the numbers always positive, or should I consider like zeros as like a special case? Okay. Yeah, let me think about how I can actually solve this question. Since I don't want to modify it in place, so I'm probably gonna just initialize a dummy head for to contain the result of the linked list. So I need to think about how we can carry the variable. So I can have a variable that stores the carryover value from each addition. So every time we do like 9 plus 2, it'll hold that 1 and carry it over. Does that make sense? Okay. And then of course we're just gonna traverse through each of the linked lists node by node and just add the corresponding digit. Okay. I might just start off by coding this step then, just to make it a lot clearer. So yeah, so I'm gonna initialize a dummy node, and that would just help with building the result list, because you always want to return the dot next. So initialize a dummy node, and it'll help build the linked list. And this will simplify handling edge cases, because what if we have empty lists, you know? If that makes sense. So dummy equals list node. So this is how so this is my dummy node variable. And I would need a pointer to the current node in the result list. Yeah, pointer, yeah, okay. So this is a pointer. Here, let's make the comments more structured. In the result list. Okay. And like I said earlier, let's initialize the carryover variable to 0. We're gonna have to decrement and increment this later on. And let's traverse through both linked lists. Yeah, so we're gonna traverse through both linked lists, but we need a condition to know when to stop. And that can be, trying to think. Okay, so we can have while list1 or list2. So while both of them are, while both of them exist, we can, trying to think of a good way to implement this. Hmm. Okay, so in the linked list, they're gonna have values, so we want to have a way to actually extract those values and hold it inside a variable. But let's say a linked list like list2 is exhausted, right? If that's exhausted, then we can store a value of 0 inside of it. That way we don't have any way of adding unnecessary numbers. And this will handle like an edge case. So we can get the value of list1 or 0 if list1 is none. So if list1 else none, and let's comment that. So we're getting the current value of list1, and if it doesn't exist, append, just get 0. And we're gonna do the same thing for the second one. For the second linked list. Does everything make sense right now? So getting the current value of list2, and if it doesn't exist, just get 0. Yeah, so now we have two variables that holds the values. So that's very good. Now we want to do the calculation step that we mentioned earlier. So every step that we do while we traverse, we want to have a way to calculate the sum of the current digit. And also, we have to keep in mind that we have this carry variable. This carry variable will also be added to the total. So we'll use the val1 and val2 variables that we had right here. And then we'll also add the carry. So sum of every step. So this is the sum of every step. And let me just slide it over right here so it's a lot more visible. And now we have to figure out a way on how we can actually calculate the new carry. And let me just think for a few seconds to actually figure out if we can do a carry or not, because we have to figure out when we actually increment the carry to a 1. So, okay. 1 second. Now give me like 5 seconds to think. Okay. So, Okay, so a good way to detect the carry. So we know we have this total variable, right? If the carry is greater than or equal to 10, so if it's greater than or equal to 10, that's how we know when a carry needs to be done. So we have a way to detect a carry. And to detect a carry, if the total is greater than or equal to 10. Does that make sense to you so far? Do you agree with this step? If not, it will just, yeah. Otherwise, yeah. Otherwise, it would just be 0. Yeah. So Yeah, we can do that by just doing carry equals total divided by 10. So we do double division. If it's not over 10, it'll just round down. And yeah, that looks like it makes sense so far. Okay, so from here, we have to think about what we're trying to do with this carry. So we have to think and take an account for the new digit. So, okay, so we have to take account for the new digit, and we can just use modulus, and we just mod it by 10. And that's just the remainder when the total is divided by 10. So the new digit when the remainder is divided by 10. So like I said, we can just do current.next. So we're looking at the next value, and we'll do total modulus 10. Okay. So this what this line does, it just creates a new variable or a new node, and it just computes the digit that we were going to put in that place. And now we have to just move the current pointer to the next. And we can just do that to current equals current.next. And yeah, so we're just moving the pointer, the current pointer, to its newly created node that we just created. Okay. Now that we have that, I need to think about some possible edge cases. And we have to also consider how we're traversing through list 1 and list 2. So we can just check if list 1 exists. If it does, let's start by commenting, sorry. Check if list 1 exists. And if it does exist, we move the next node into the next list if it's available. So we're just checking if list 1. So if we know this will run if list 1 exists. Okay. This moves list 1 to the next. This will make list 1 have the next value. And if list 2 equals list 2.next. And this comment will just be the same for this one. Check if list 2 exists. Okay. Now, I think that's all the checks that we need. So let me just scroll up, and before we try to submit the code, we actually just kind of make sure everything's good. So yeah, like I said, we have a dummy node, and that node is what we're going to be using to return at the end. And we have a pointer to that current node in that result list, which is the dummy node. And we have the carry to take account of all the carries that we have. And then now we have to consider traversing through both of the linked lists. And I have variables, and the way this while loop runs is it checks if list 1 is at the end or is list 2 at the end. So it keeps running until one of these hit the last node of the linked list. And I have a variable val1, and val1 holds list1.val. If it doesn't have a value, it just gets 0. And val2 holds list2.val. If list2 doesn't exist, it holds 0 as well. And now every step, because we know that we want to calculate a new total for every step, so we have a sum of every step. So we have total equals val1 plus val2 plus carry, because we have to also take account for the carry that would occur if it exists. But we have to also detect if there is a carry that would exist. So if the total is greater than or equal to 10, it will detect a carry. But if it doesn't detect a carry, it will round down and have a 0. And that makes sense so far. And I'm checking if the new digit, for the new digit right here, for the very next one. and if the remainder is divided by 10. So yeah, and I move the current pointer to the next one. So current equals current.next, and I check if the list 1 exists. So for every step, we're checking if list 1 and list 2 exists. So this moves the pointers to the next value. So list 1 will be at the next node. So in this instance, 5. If list 1 was at 5, it'll be at 6. If list 2 was at 7, it'll be at 0. And yeah, that looks like it's correct. And we want to return dummy.next because dummy actually adds another variable to the beginning of the list. So we just return dummy.next. I think this looks correct. Let me just try running it. I got 2 out of 3 test cases correct. And this is the one that isn't correct. Okay. I need to look into why this is not correct first. Okay. Let me just rescan the code and work our way back up. So we have a dummy, and that contains it. That's correct. We have current to dummy. That's correct. We have carry to 0. Yes. And we're checking. Oh, I see what we're doing wrong right here. So if you look at this input, 9999999, you can see that we're actually having a lot of carries in this, but we're not considering it. We do 9 plus 9, that's 8. And then we also have to consider the one that passes over. So 9 plus 9, it's still 9, and it still keeps carrying on that 1, but we're not checking for it. So we want this to keep running actually if a carry exists. So if a carry is 1, that means that we keep running it. And this should honestly work. Yeah. And just to make sure, I don't want to like say that it works, but it doesn't work. Yeah, it works, and it's pretty efficient. Yeah, let me just explain the time complexity as well. So yeah, let me just look and scan through the time complexity. But we're for sure it's not just going to be a simply O of n, because we also have 2 linked lists that we have to consider. So there's going to be 2 variables in our space and time complexity. So we have to consider m and n. And it's honestly like pretty quick. I think the time complexity is just honestly O of m and n, where m is like list 1 and n is list 2. And for the space complexity, it's the same. It will be O of mn. Because we create a new linked list, right? And we're taking account and holding all of those values. So we're creating a new linked list, so we have more memory that grows in that dummy node. So yeah, and I can quickly, if you want, I can quickly explain why I created a dummy node. Yeah. So okay, what if we have an empty linked list? If we have an empty linked list, there's an edge case. Something will be very wrong. We're gonna actually get like an error that we're not returning a linked list. So that's why we want to do dummy.next. We do dummy.next because dummy creates a whole new node. So it has a whole new node right here, and we want to return the existing nodes that are actually the sum of what we need. Does that make sense? And like I said, time complexity is O of m and n. But this can simplify between one of these. So we might run into a case where one of the lists are actually longer than the others. So we can have list 1 with a length of like 4, length of 4, and list 2 where it's like the length of 3, right? So when we have a right here. So when we have a list 1 that's a length of 4 and list 2 that's a length of 3, we have to take into account that we're really only traversing at constant time, and it's gonna be at the max of one of these. So yeah, it'll be the max of one of these, and we can just submit. And I already submitted it earlier anyway, but yeah, thank you.